Okay. So 5.5. So 5.4 was undoing the basic rule. Okay, so integrating with basic. This section is going to be undoing the chain rule. Okay, so they have this definition highlighted. I'm not going to go over it right now because I'm going to have you guys come up with how to undo the chain rule. Okay, so on question number 1, we're just going to derive this. Okay, so do you remember how to derive with the chain rule? That's product rule.
Exponent to the front.
Okay.
Times the middle piece to the third, in that case.
Yep.
And then times 5.
Times 5. Okay, so what you said, which I'm going to say in a more blanket statement-y way, you derive the outside and then multiply by the derivative of the inside. Okay, so we derive the outside, Garrett. Okay. Okay, so you derive the outside times the derivative of the inside. Okay, now you would normally simplify that, but I'm not going to. I want you to think about how you would undo that. Okay, so now on question number 2, we're going to undo that. Okay, so how would we undo that? Okay, so we would integrate the outside. Okay, so we would go, okay, so we got this 5, and then we're going to integrate it, so we'd have 1 plus 5x to the 4th over 4. The whole thing. I mean, you can put it over just the 4. I'm just going to do the whole thing now. And then what about before we multiplied by the derivative of the inside? So what are we going to do now? We're going to, what's the opposite of multiply? We're going to divide. Okay, so we're going to divide by the derivative of the inside. So what's the derivative of the inside? 5. So watch where I divide by it. I'm just going to put it in the denominator. Okay, any places dividing is all going to go on the same bottom. Okay, so at this point, well, I should technically say plus c. Now, if I simplify this, what cancels out? The 5's, okay? So, my integral is 1 plus 5x to the 4th over 4 plus c. Okay, and we could, if we wanted to, undo it and derive it and see if we did do that correctly. Do you want to do that? Feel good about it? Feel confident? Okay. Okay, so this little note that they have in the book says you hook on. Okay, so before the hook on factor was the derivative of the inside. Okay, so the whole idea is that we're unhooking. Okay, we're undoing it. So the unhooking part is dividing by the derivative of the inside. Okay, so let's do another one. Let me erase this big giant circle. Okay, so how would I do question number 3? So I've got this quantity, so I've got 3x minus 1 to the 11th, and then I divide by 11. Okay, and then I'm going to also divide by 3. So would everybody agree that the integral of this is 3x minus 1 to the 11th all over 33 plus c? Good there? All right, now question number 4 is a little bit more awesome looking. Okay, the first thing that we need to figure out is what piece was derived and what piece is going to be the piece that we're going to call the parenthesis piece. Okay, so one of them is going to be the derivative of the other one. Well, one of them is the derivative and one of them is the parenthesis piece. The first one is the derivative, right? Okay, so this is the one that I'm going to keep as my piece that was in parentheses like we did before. So that second one is the one I'm going to integrate. Okay, and I'm not going to touch this other one till later. Okay, so if I integrate the second one, what is the integral of that? Be t cubed plus t squared to the second. And I'm just going to say over 2, and I'm just going to put a big fat line, so everything is over 2. Okay, so then if I integrated that, I then need to derive by the inside of that. What is the derivative of the inside of that? 3t squared plus 2t. And what do you notice? Ah, they do cancel. What's that? Not necessarily. They might not say it. They could put it in any order. Good there? Is this easy or hard? Medium? Easy.
Because the first one's the derivative.
Why? Right. So if you like took the derivative of both of them, one of them is the derivative and the other one isn't. One of them is the derivative of the other one. So the one that's the derivative is the one that you don't integrate. Uh-huh.
This is so rude. Never mind.
So one thing that maybe you guys are noticing, what is happening every time that we integrate? Well, not every time, but most every time. You have to cancel. A lot of the times, not every time, but every time there's a variable involved, that derivative of the inside has to cancel with the stuff that was originally on the outside. Okay, there's usually going to be some canceling. Okay, if there's constant numbers, you're okay, but if there's variables, that's a problem. Okay. Well, left over. Okay, so question number 5, I'm going to rewrite this because I don't like that there's a squared in the bottom. I want to write this as a product. So I'm going to pull that quantity up and say that that would be the same as to the negative 1/2, right? Okay, so which one is the piece that I'm going to integrate? This one, right? The 4x cubed minus 5. That's the piece I'm integrating. It's always the piece that's in parentheses, usually the piece that's got the exponent. Okay, so like the last question didn't have an exponent, so you didn't really know. But if there's one that has an exponent, that's the one that you integrate. Okay. Okay, so I've got 6x squared. Now I'm integrating this piece, so 4x cubed minus 5 to the 1/2. So if I divide by a half, that's technically multiplying by 2. I'm going to throw that in the front. And now I'm going to divide by the derivative of the inside. What is the derivative of the inside? 12x squared. Which magically, boom, boom, does cancel. Okay. Okay. Number 6, let's check this one out. This is an interesting question. Okay, so right away I would say, okay, I've got this piece, okay, that I have to integrate. Okay, so I would go y cubed plus 1 to the 3rd all over 3 times the derivative of the inside. What's the derivative of the inside? 3y squared. Okay. What?
Since you're deriving y,
Oh, no. Mm-mm. So, there's a problem. What is the problem? There's a what? Say that again.
Is that right?
Yeah.
Okay. There's an exponent on the bottom.
There's a variable on the bottom. You said variable last time, but yeah.
He said
Oh.
variable. I said exponent.
Oh, okay. Well, combine your powers. There is not one that we can cancel that was originally hooked on. Okay? So this is a problem. We cannot integrate using this method right now. We cannot use the general power rule to integrate this. No hook on. We can't do it. Okay, so how are we going to integrate this? It's still possible to integrate it. How are we going to integrate it? Can you go back to the original and think of another way to write that? Can we manipulate the original at all? We could do the foiling through method.
Wow.
Good. Okay, so let's FOIL it. So if we FOIL it, we get y to the 6th plus 2y cubed plus 1 dy. And now we can just use basic integration to integrate it. So what's the integral of y to the 6th?
It's squared. So
Y to the 7th over 7. What's the integral of 2y to the 3rd? Okay, so 1/2 y to the 4th. Everybody okay with that one? What's the integral of 1? Y today on this problem. And then plus c. And so don't forget, by the way, all of your integrals should always have a plus c at the end. Still a plus c. Good there?
she integrated it. So it's
All right, so the next method, so this is method number 3 now, is called U-Substitution. Okay, so U-Substitution is basically when you can't use the other two methods. Okay, and you have something that is a little bit more awesome. Okay, this box gives you step-by-step of what you need to do. It is very clear and very exact. Okay, so we are going to follow these exact steps as we go through these next two problems. Okay. All right, so they actually call it a reticand, which is kind of a pretty gnarly word. I'm going to call it the, well, I don't know. It's just the piece that's in parentheses. Okay, so for question number 7, I don't like it written as a radical. I want it written in exponential form. Just like always, I'm rewriting it as x minus 1 to the 1/2. Okay, so the first thing I have to do is identify what my u is. Okay, so u substitution, you're going to rewrite the integral in terms of u. So see all those x's? We are going to replace all of the x's with u's. Okay, so the u is going to be the piece that's in the parentheses. So what is my u? X minus 1. Okay, so u is x minus 1. So the next thing I want to know is what is the value of x? Okay, so if I look at my red piece and solve for x, what is x equal to? U plus 1. Good. Okay, I am then going to derive that. What is the derivative of x? 1. 1 dx, technically, right? If you want to be technical, so I'm going to say dx, because you do actually see a dx in the original integral. What is the, what is the derivative of u? Du. And what is the derivative of 1? 0, so I don't need to say that. Okay, so now what I'm going to do is I'm going to replace the u piece, that little quantity with a u to the 1/2. I'm going to replace the x with a u plus 1, and I'm going to replace the dx with a du. Okay, so I'm doing substitution, kind of 3 pieces of substitution here. Okay, so my x is u plus 1. x minus 1 is the same as u, so I'm going to say u to the 1/2. And dx is equal to du in this case. Okay. So at this point, I am now going to simplify my integral and just integrate. Okay, so I would just distribute this u through. So what is u times u to the 1/2? U to the 3/2. And what is 1 times u to the 1/2? U to the 1/2 du. Okay, so now I'm just going to simply integrate the u's. So what is the integral of u to the 3/2? Can you guys flip that in your head? So it'll be 5/2, so you go 2/5 u to the 5/2. Everybody okay with that? Because you're adding 1. Okay, on the second term, the integral of u to the 1/2, if you add 1, would be 3/2. So we multiply by the reciprocal. 2/3 u to the 3/2 plus c. Okay, and at this point we are almost done. We need to rewrite it in terms of x. So all I have left to do is to substitute my x back in. Okay, so u is the value of x minus 1 and that is done. How do we do on that one?
So this is just a faster way to integrate.
I would not say it's faster at all, but it's a thank you, a necessary way. I don't think it's easier. I think it's more complicated.
Like radicals, easier.
So wait, why?
Yeah, well, it's not just for radicals. You can use it for any exponent. Why don't we start with an easier one? That one was pretty easy.
Why?
That was a pretty easy one. What? Because there's an x on the outside. Because, so like if we had gone back to, and tried to do the regular rule, the power rule, when you derive the inside, you would just have 1, and it would not undo that hook on power, the x that's in the front. Since that wouldn't undo it, you have to use the U-Substitution. It's the only way to do it. No, because of the 1/2. You can't distribute through an exponent. Okay, so let's do question number 8. This one is a little bit more complicated, but not a ton more complicated. Okay, the first thing I'm going to do is just simply rewrite it so that I write it as a product. So this is going to be 2x plus 3 to the negative 1/2 dx. Okay, what is my next step? Okay, we need to identify what the u is. Okay, so the u is what? 2x plus 3. It'll always be the piece that's in parentheses with an exponent. Okay, so you can use this rule anytime you have an exponent, a quantity with an exponent. Okay, what do I do next? Okay, solve for the x. Can we do this in our heads? Because you would subtract 3 divided by 2. So u minus 3 divided by 2. Which, since we're going to derive in the next step, that's the same as 1/2 u minus 3/2, right? That's the same thing. Okay, so once we solve for x, what do we do next? Okay, so we derive it. Okay, so deriving it, the derivative of x is d of x. Okay, what's the derivative of 1/2 u? 1/2 du. There you go. 1/2 du And then the derivative of negative 3/2, 0. Okay, so now we do our substitution. This is going to get a little bit awesome. Okay, so on my first quantity, I have 2x minus 1. I'm replacing the x with u minus 3 over 2. Yes, they can. If you're there, go ahead and cancel. I'm not going to write that yet. I just want to make sure I write everything. Okay, I'm going to write my quantity as a u. So that's going to be times u to the negative 1/2. And what is the value of dx? 1/2 du. Good. Okay, so see, I basically did 3 substitutions in one right there. Okay, so now I have to simplify this so that I can integrate this with basic rule. Okay, so Alex did notice right away that the 2's canceled. Can I go ahead and say that I have u minus 3 minus 1, so minus 3 minus 1 is minus 4. Can I put the 1/2 in the front? You see that 1/2 that's in the back? I always like my 1/2s in the front. du is the very end, yes. The 1/2, so see how it's grouped with the du on the step above? I just pulled it in the front. 4? Oh, yeah, negative 3 minus 1. Okay, so then what should I do? Not yet. I'm gonna do basic. Distribute. Okay, so can I distribute 1/2 and the u to the negative 1/2 in 1, or is that too confusing? Distribute the 1/2 and the u to the negative 1/2? Or should I do that in 2 steps? 2 steps? Okay. So I'll keep the 1/2 out first. So then I'll distribute this one. So u times u to the negative 1/2 is u to the 1/2. And then I have minus 4 u to the negative 1/2 du. Okay, and then I distribute the 1/2. So then I have 1/2 u to the 1/2 minus 2 u to the negative 1/2. Okay, so now I'm at the part where I can integrate it just using the basic rule. Okay, so what is the integral of 1/2 u to the 1/2? We can go slow. Let's pull the 1/2 off. What is the integral of u to the 1/2? 3/2, right? So u to the 3/2. So can I say if we're going to divide by 3/2, that's the same as multiplying by 2/3? 3/2, good. I'm going to pull the 2 and just integrate u to the negative 1/2. So what's the integral of u to the negative 1/2? So, okay, so if it's u to the 1/2 divided by 1/2, that's the same as multiplying by 2, right? So times 2 u to the 1/2. So then we got our plus c. Okay, so now if we just simplify, on the first term, what do you notice? The 2's cancel, so I have a 1/3. Can I substitute right now? Is that okay? Or is that going too fast? Go slow? Later. Got it. U to the 3/2 minus 4 u to the 1/2. Okay, so now I'm simplified. My last step will always be to plug that u back in. So what was our value of u? 2x plus 3. So I plug that back in. 2x plus 3. How do we do on that one? Do you feel good about this? Like you're ready to do it on your own, or should we do a few together?
Go over regular substitution.
The regular? Sure. Do you want to just start with like problem number 1 and we'll do it together?
Not the regular, but where you get the substitution.
Oh, a U-substitution one? let's see. Let's go to this one.
All this time,